This is a brief demo video to show how YATE, yet another telephony engine, can be used with SIP trunking in order to do a whole bunch of things. So first of all, the system I'm connected to is a slicehost.com virtual host. So it's running CentOS 5.5, and it's only got 256 megabytes of memory, actually only 245 available in the kernel. Asterisk, for instance, won't even start on a system like this. So I'm going to go ahead and start up the IF-top, which is the internet monitor. Essentially, the width of these bars indicates how much bandwidth each connection is consuming, and then we have some general statistics over here. And I'm going to start up top, the process monitor. I'd like you to see that even on this incredibly small slice, YATE still doesn't cause any appreciable amount of processing to happen. So I'm going to go ahead and start up YATE here, and I have a little custom application that I've written for YATE. What happens is I log in, I call in actually from any phone. It starts playing some music. There's a little playlist. The star and pound buttons move it forward and backwards, and hitting any numbered button causes that particular song to start. So I'm going to, from my home phone now, go ahead and call in, and if you watch this window down in the bottom left-hand corner, you should see the call initiate in just a moment. So note in particular, we're only using about 1 kilobit per second bandwidth overall, plus a little bit for these monitors, but really there's no bandwidth, so you should see that spike in a moment as the call comes in. So in just a moment, we got the call, and we started playing CCR's Fortunate Son. I'm going to go ahead and turn that off of speakerphone so that you can hear me. But in a moment, you'll see the call duration tick up to indicate the call's still going on. If you look up here at the Sounds Manager, you'll notice we're doing just about 78 kilobits per second inbound and outbound, which is exactly what we'd expect for a GSM ULAW channel. And what's particularly interesting about this is we're decoding audio, we're sending it out, we are running an entirely software-based SIP stack, and we're doing all this networking stuff, and we're still not even causing enough of a hit on this little tiny virtual machine to cause any appreciable load. So we're like 1% load right now. Now, to show you that this isn't typical, I'm going to go ahead and use my cell phone to start up another call into the system. And in a moment, you should see a second call starting up down in the bottom left-hand corner. And there it goes. So it's going to start playing Fortunate Son. And let's just play a little, I think, well, maybe not that one. Let's play a little classical music on that phone. So you noticed we're doing a lot of disk access, a lot of file access, and we're simultaneously running several calls, and it's not a problem. Now, to give you a sense that this really is decent call quality, I'm going to go ahead and open up Blink here and directly connect. I'll put this guy down here so you can still see the totals up here. I'm going to go ahead and directly connect to the system. So we'll see another connection open up in a moment. And you can probably hear my audio a little bit coming over. So we've got 3 simultaneous calls going on. We've got, and with those 3 simultaneous calls on this little tiny slice, we're not even doing anything. Now, to demonstrate that it really is performant, I'm going to go ahead and push some buttons on here to swap around songs. Oh, Eye of the Tiger has a little silence in the beginning. By the way, you notice here the first call I did just ended its first song and went on to another. So in the space of a few seconds, we had to change several songs, completely redo all of our encoding and decoding, and there's absolutely no stutter. I'll just send a bunch of commands back and back, and you can see that it's really not having any bad effect on the system. And so this is admittedly only 3 users, but it's running on a virtual machine. So all of my audio processing is actually being run in the virtualizer, not on the actual hardware. In any case, this is really the core of the system that's required for using a calling card. The difference is that rather than using rather than using audio playback, we just connect them to outgoing SIP channels. But I think that on dedicated hardware, on a 100 megabit connection, we could certainly see many dozens of simultaneous calls on one system. So I think YATE is just a wonderful, wonderful platform for all of this. One other caveat, I'll be sending along with this video information for how to access this system yourself. It automatically cuts off after 300 seconds or 5 minutes. So thank you very much for watching the demo, and this has been a presentation of Painted Rock Communications.